Hello viewers, in today's class we are going to discuss one important and very interesting problem from Maxima and Minima, right? And here we are going to take up this problem in which we have to find the maximum and minimum value of this expression, that is the g of x comma y is equal to 3x square plus 6xy plus 5y square when we have the condition that is x square plus y square is equal to 1, right? Now this problem can be solved by using the concept of derivatives, right? But here we'll avoid that method and we'll make use of some trigonometry, right? So let us start. Now here what we will do, let us take x is equal to say sine of alpha, right? So here I will make some trigonometric substitution and we'll take x is equal to sine alpha and y is equal to cos of alpha, right? And when we take this substitution, then we can see that this condition is readily satisfied, right? So we have sine square alpha plus cos square alpha is equal to 1, right? So this is a well-known result in trigonometry. So now let us substitute x equal to sine alpha and y is equal to cos alpha in this expression whose maximum and minimum value is required, right? So now we have g of sine alpha and cos alpha is equal to 3x square. So we have 3 sine square alpha. Here we have 6 times sine alpha cos alpha, and here we have 5 times cos square alpha, right? Now here we'll make some important identities from trigonometry. Now let us make use of some important identities from trigonometry. So we know that cos of 2 theta is equal to 1 minus 2 sine square theta, right? So sine square theta can be written as 1 minus cos 2 theta divided by 2, right? So this is the first result that shall be used here, right? And similarly, we know that cos of 2 theta is equal to 2 cos square theta minus 1. And from here, cos square theta can be written as 1 plus cos 2 theta divided by 2, right? So this is the second result which shall be used over here, right? And see, here we can write this middle term like this, right? So we can write 3 times 2 sine alpha cos alpha, and then we have 5 cos square alpha, right? So 3 to the 6. So now we have the well-known result for sine 2 theta, that is 2 sine theta cos theta, right? So now making use of these three important results, we can now have this expression as 3 times. We have 1 minus cos 2 theta divided by 2. Then we have 3 times sine of, here we can take alpha because here the angle is alpha, right? And here we have sine 2 alpha because 2 sine theta cos theta is sine 2 theta. And here we have 5 times, from here we have 1 plus cos 2 theta divided by 2, right? So now we can rearrange the terms here. So we have from here we have 3 over 2 minus 3 over 2 cos 2 alpha, and here we have 3 times sine 2 alpha. Then we have 5 over 2 plus 5 over 2 cos 2. Here we have for theta we can write alpha, right? So now let us collect the terms, and we have 3 over 2 plus 5 over 2 is 8 over 2, that is 4, and here minus 3 by 2 plus 5 by 2 is 2 over 2, because minus 3 over 2 plus 5 by 2 is 2 over 2, that is 1. So we have simply cos of 2 alpha, and here we have plus 3 sine 2 alpha, right? So now we can write this expression as 3 sine 2 alpha plus cos 2 alpha, and here remember the coefficient of cos 2 alpha is 1, we can take it as 1, and here we have plus 4, right? So now viewers, we have obtained this expression, right? Now let us make use of one important result from trigonometry, right? Let us consider an expression P which is equal to A sine theta plus B cos theta plus C, right? So suppose we have an expression of this type, right? Then the direct value of the maximum and minimum value of this expression is given by, that is maximum of P is directly given by square root of A square plus B square, and here we have plus C, and the minimum of P is given by negative of square root of A square plus B square plus C, right? So what we have discussed, suppose we have an expression of this type, that is P is equal to A sine theta plus B cos theta plus C, right? Where A, B, C are some numbers. Then the maximum value of this expression is given by square root of A square plus B square and plus C, and the minimum of P is the negative of square root of A square plus B square plus C, right? So this is a well-known result in trigonometry, and here we have reduced this expression to this expression by making this substitution, that is x is equal to sine alpha and y is equal to cos alpha, right? So now if we compare these two expressions, that is this one and this one, right? So see here the value of A is 3, right? A is 3, and obviously theta is 2 alpha, right? So theta is 2 alpha, and the value of B is equal to 1, and the value of C is equal to 4, right? So now we can make use of this result to get the maximum and minimum of this function, that is g of x comma y, right? So the maximum of this function g of xy is given by square root of A square plus B square. So A is 3 and B is 1. So we have 3 square plus 1 square, plus here we have the term C. So we can now write 4. So this is 3 square is 9, 9 plus 1, 10. So we have square root of 10 plus 4, right? So the maximum value of G is the square root of 10 plus 4, right? And similarly, the minimum of g of x comma y is given by this expression. So we have negative of square root of 3 square plus 1 square, and here we have plus 4, and this is minus square root of 10 plus 4, right? So viewers, this is how we can find the maximum and minimum value of this expression as square root of 10 plus 4 and minus square root of 10 plus 4, right? So this result can also be written like this, that is g of x comma y is greater than or equal to, here we have negative of root 10 plus 4, and here this is less than or equal to square root of 10 plus 4, right? So this is the minimum value of this function, and this is the a maximum value of this function, provided that this condition holds, that is x square plus y square is equal to 1, right?